welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. I'm Alice, education lead at ZKM. Today I'm joined here with co-host Pavel, who is DevRel lead at ZKM, and our guest Ayush, who's co-founder of LayerEdge. Thank you so much for being here today, Ayush. We're really excited to have you.
Thank you, Alice.
Yeah, thank you. Ayush, I'm wondering if we can first start with an introduction of yourself. How did you get involved into the Web3 and then also the Bitcoin and ZK spaces?
Yeah, sure. So, my introduction to crypto was with some of my personal needs. So, as you know, while you live in India, it's difficult to access the foreign products in the old days because the financial system is a little bit more regulated. If you need some things, I want to buy some things from Germany, some tech gadgets. So for that, the only legitimate payment gateway that I found in 2016 was Bitcoin. And through Bitcoin, I was able to make a transaction and get the things that I wanted, imported properly. Because I was pretty young then and I didn't have the credit cards or things like that. I just had a bank account and I didn't know how to do the Swift payments. So this was my first introduction to Bitcoin, and I love the concept that you can actually interact with everyone, because for me it was a very new time for me for the internet also. So we were exploring different communities, meeting people from different places, and now you can actually do some kind of transactions with them. So it was pretty fun. And it was close to 2018 I went in from a dev perspective, because that was the time I just graduated from IIT in computer science, and then I started I started focusing more on the security aspects. That was the time I joined Samsung Research. And fun fact, if you are using any of the Samsung devices, I was one of the member of the team who developed the authentication systems at SRIV. So if you're using the Samsung authentications any of the way, then you're using some of my code there. So yeah, it was a fun detour, and it was really love Bitcoin. And the thing was when I was working there, I got a really challenging work at Samsung and in the Web 2 space, but Web 3 was something that I personally liked because of my personal touch and the concept of total freedom. And that's when I decided to move from a Web 2 company to Web 3. I joined Gnosis as I was a tech lead at Gnosis Builders, where we did develop a lot of things, and that was my foray into crypto and meeting new people, learning many new things. And as I told, my niche was in majorly security, so I just brought that thing here, and here we are developing, trying to create a secure internet that's pretty much backed by Bitcoin.
Yeah, nice. I really love how you first got your introduction by doing those cross-border payments, and then you looked into it more of the dev perspective, and then got your start both from Web 2 and then transitioning to Web 3. So that sounds really great. And you mentioned that you guys are now really focused on trying to develop this Bitcoin backed internet. Curious to hear how you see the Bitcoin ecosystem evolving in the next couple of years, and also wondering from your perspective what ZK's role is in it.
So going from how I looked at Web 3, because of the time of I entered, I thought Bitcoin and Ethereum are pretty much very similar, but in the Ethereum space we had smart contracts, and they were pretty much revolutionaries, because the things that smart contracts enable were tremendous new things, the whole DeFi ecosystem. But on the Bitcoin side, we just had Bitcoin scripts, and that too, that not that functional. With the help of Taproot, now we got a certain way of doing some sort of pseudo programs. That's not exactly a Turing complete language, but you can do a lot of things. And that was a place that I started looking Bitcoin more seriously, from how we can develop new things and build on top of it. Because what intrigued me about Bitcoin is it has the highest amount of total value lock on a chain, and that value is basically untapped. Till now, people use Bitcoin just for basic transactions, nothing else. But if we are able to tap into that liquidity, the amount of DeFi or the things that we can actually enable on the Bitcoin would be on far larger scale compared to Ethereum. That's why when we saw like a need in the market that there can be different layer 2s that can be built on Bitcoin, we started like building a layer 2. Like, so LayerEdge was initially a chain which was a layer 2 on Bitcoin, and then we realized what like that most of like the Bitcoin layer 2s are not well secured, and they are not actually leveraging Bitcoin security in any of the ways. And we wanted to make a change there, so we decided hammering down on the security aspects and tried develop like the initial version of like what we are building right now called HMDA. And at that point of time, like we got a lot of queries from many of our chains which were the competitor. They wanted to know how we are doing things, they want to talk about it, and they actually asked us that can you help us in like fixing our security infrastructure. And at that point we realized that there is a very big niche in basically making sure that the chains are secured on Bitcoin and they can leverage Bitcoin security. And then we pivoted from like building a chain to like building like a security stack on which any chain can actually get themselves secured on the Bitcoin. And like as my experience, like my past was also like heavily focused on security, so we just deep dive into it. And from the initial days, like we got a lot of traction from many of the partner chains, and then the journey went on from there.
And then you mentioned that like a lot of Bitcoin L2s right now are not exactly secure, and that's something that you're trying to address. But also interested in hearing some of the different challenges that you see with other kinds of scaling solutions on Bitcoin, like for example with sidechains. What kinds of trade-offs exist in this on the security side as well, and how it compares to maybe like roll-ups in terms of scaling?
So yeah, so like if you look at the side chains, so they do not leverage Bitcoin security in any of the manners. They have their own set of validators which secure their chains. So it's very akin to like the early role like side chains that were developed on Ethereum. So they are not secured on Bitcoin in any of the way. What they do at max is store their hashes of the blocks on the Bitcoin chain, but they are not like binding. So if the validators want, they can still change that, and basically that attestation on Bitcoin doesn't mean anything like for them till now. So that's why we found that if any chain is not basically secured on Bitcoin, and even the bridging solution is pretty much centralized, then basically they are L1s which are attached to Bitcoin with the help of a bridge, and they're not like true rollups or true L2. So what we believe a true L2 is it should have like two characteristics. First, its state transition should be secured on Bitcoin. Basically, the state of the chain is secured on Bitcoin. And second, whenever we do any kind of bridging, that should be as trust minimized as possible. Like ideally should be trustless, but on the Bitcoin we have certain limitations. So on that, what I believe the correct solution should be like of one of n. Like with one honest validator, the whole network should work very well.
Got it. And also know that you guys are both leveraging BitVM and ZK for LayerEdge. So curious to see if you can provide us some insights on the specific advantages that like both BitVM and ZK brings, and also the like specific parts of the BitVM stack that you guys are using.
So like for everyone like who is new to like the Bitcoin space, so BitVM is basically a technology through which we can simulate like pseudo smart contracts on Bitcoin. What we mean to say is like you can create a very close to Turing complete language on which you can do multiple type of smart contracts using the Bitcoin scripts only. So how they work is basically there is a proposer who just proposes a new state, and there can be multiple different verifiers who can verify the chain and then raise a condition that this is faulty. And this basically this goes on for a certain period of time, and then once the state is finalized, then basically the challenges end. So there is a challenge between the challengers and the proposers, and whoever wins the challenges, their state is actually valid. So through this we can create like smart contracts. So how we are using it is in two ways. First is we are using this for like this whole system works on the state transitions. So like for the core BitVM, they are actually using it for doing the transactions. We are using it for verifying the state change. So it is very similar because in transactions also there is a state change and we need to verify that. So by this method we can actually verify that. And second, we are like also looking at the bridging aspect, so that whichever chain that we are working with can have a very trust minimized bridging. So for the bridging part, it's actually like I can say there can be slightly different modified version, but if you say it's 90% exact BitVM with a slight twist of LayerEdge, what we are doing for like making it accessible for like multiple different lines. So the original system is basically built for one-to-one. We are making it compatible for like one-to-many.
Got it.
And just as a clarification point, so you mentioned that it is an optimistic process,
Yeah.
that the optimistic challenge period, and then I guess there's the bit of ZK involved. I guess
Yeah.
where would ZK fall into place, and why not just make it a fully optimistic process?
Yeah, so it's like a very good question, like why we had to introduce ZK. So like there are two different reasons. So one, if you see the whole landscape, like majority of the chains are either POS chains or the ZK based chains. And the reason why we chose like ZK chains is like the POS are very well supported by Babylon and they are providing like great economic security, but no one was working for POS chains. So we are at the base level, the verification is working optimistically because Bitcoin scripts do not support like the ZK verification natively. So like the ZK verification happens, but it's like OPZK, the optimistic verification of the ZK proofs happen there. And why we're using ZK is we can take multiple different ZK proofs that represent the state change of each and every chain, and we can do what you can say aggregation. Basically take two different ZK proofs, aggregate into a single proof and do it recursively. So we create like a whole binary tree and we get an aggregated proof. And now this aggregated proof basically represents the validity of the state changes of all the different chains. So why we are doing this whole complicated process is to make sure that Bitcoin is actually scalable. Because if you see the Bitcoin, a single block has just 4 MB of space, and if you see the computational capacities, they are even lower. So like if you try to do that, it's like pretty expensive doing any of the operations. So what we believe is there will be like thousands of chains on Bitcoin, and if they are, let's say not even 1,000, let's say there are even 50 chains, the current network won't be able to support it and will get congested. So through our aggregation process we can scale it a lot more, because what we can do, we can take 50 chains, aggregate the proof into a single aggregated proof, and the main network just has to verify a single proof, whereas the whole ecosystem, 50 chains are now verified. So through this process we can bring like Bitcoin based security to like multiple of like ZK chains that are currently building on Bitcoin.
And on that topic of proof aggregation, are there certain scenarios where it may not exactly be needed, or there's some like limitations or drawbacks to using them? Like I'd imagine for proof aggregation, there is maybe some increased computational expenses that are needed in order to do it. Are there any sorts of drawbacks or trade-offs that you need to consider?
Yeah, sure. So if you look at it, there are certain drawbacks and there are certain limitations to it. But like so, how the things work is if you're using the proof aggregation service like LayerEdge, then you are using us for doing the settlement. So your settlement is little delayed, and it's not that much delayed because on the Bitcoin the block time is close to 10 minutes. So because of the fundamentals of the Bitcoin blockchain, that delayed settlement doesn't happen with us, because the chain gives us enough time to settle everything just on the same block only. Now the thing is, you are actually leveraging LayerEdge. You are getting the benefits, like we reduce your cost by 95%, more than 95%. So it will be 4%, 2%, or like 1% of the cost. So we reduce your cost, but the drawback is like you are dependent on the LayerEdge. So basically you have to run the LayerEdge verification node. So using a single node, if you're running one node in an honest way, we created a one of n model. So if a single node is valid, like you are honest, then the whole network, you can make sure the whole network is honest. But you cannot claim to be like 100% native. So you are leveraging on LayerEdge, which is aggregating, and then that's settled on the main Bitcoin chain. So just for the bragging rights, you lose something, but if you see on the technical angle, like it's all one and the same. Because on the Bitcoin also you are using one of an solution, because Bitcoin doesn't support like native verification right now. So there too you are like relying on one of an like one honest validator, and same happens on the LayerEdge. So technically it's pretty much the same, but on the bragging right side you can say that we are native.
I see, I see. And also wanted to just scope out a bit and talk a bit about verification in general. So, what are some of the challenges that are uh, currently present in implementing um, ZK proof verification specifically on Bitcoin, and how that compares to some of the other like chains that we see, for example, verification on Ethereum? What are some of the main challenges that we see here right now?
Yeah, so if you see like proof verification on the Bitcoin side, it's inherently very challenging because of the type of the chain that we are dealing with. As like Bitcoin doesn't have like native scripts, like native smart contract capabilities, so the solution that we are working on is a workaround. So this whole optimistic verification solution is a workaround, and there is a drawback, like not for us but everyone who is using BitVM, is you need to wait for the challenge period to end. So once the challenge period is over, then only your the block that you finalize is truly final. Till then there can be a challenge raise and the block state can be reversed. So the concept in the like ZK world is that once you create the ZK proof and once it's verified, the state is immediately finalized. So that cannot happen on the Bitcoin. That's like the biggest challenge. And there are certain solutions like BitVM2 who are trying to like reduce this time. But yeah, because of the non smart contract functionality available on the base layer, there are certain limitations that we are working with.
And how long does it take for, I guess, this optimistic challenge process to occur before the state is finalized via the ZK proof?
Yeah, sure. So, like this time actually is a lot varied depending on like who you ask. Because if you see, like it's a part of like the blockchain trilemma. So, if you want, we can give you like this is not just for us, but for the whole BitVM like family, everyone who's working on it. You can get a like a very good finality at 7 days time period. So after waiting for 7 days, you can get a very good finality. But if you want a rock solid result, I mean like the result that cannot be changed, so mathematically it will come around to 3 months, which is like very long time. No one's going to use that long. That's why we have used like certain basically if you're using certain good high quality machines which can compute very fast, then assuming that scenario actually occurs, then the time is actually reduced to 7 days, which itself is a big time. That's why everyone in the industry is trying to reduce it even more.
And also wanted to touch a bit about some of the proof systems that you guys support in your aggregation layers. So I know that you guys are compatible with quite a few different ones, like with Snarks, with Halo 2, Gross 16. Curious to hear about the intention of being compatible with all of these proof systems, and how providing these kinds of variety of choices is able to affect the end user's experience.
Yeah, sure. So how we look at ourselves is we look ourselves like more like a marketplace. Like if you want any kind of security solution, so like our ideal customer is a person who is building a chain for a specific use case. So if you're creating a general purpose chain, then you are like building on some philosophy. So you should focus on that philosophy. If you're using an app specific chain, then you should basically focus your efforts on building that app very well, or that specific use case very well. So what we believe is you should leave all the security infrastructure, like all the heavy plumbing of that side to us. We'll give you a very easy onboarding platform where you can directly connect to us, and you can leverage like Bitcoin security without putting any efforts on top of it. So we want to make it as simple for our user as possible, so that like they can actually leverage the whole Bitcoin security at very few changes on their end. That's why we are making us compatible with every single ZK proof possible in the world, so that if you are using anything, any chain, any kind of technology, we are agnostic to it, and we can provide you like the best security at like minimal efforts, so that you can focus on what you're good at. And ultimately what it will lead is like great apps, great dapps, and that will actually bring in like users, because ultimate like goal of everyone here working in the web3 is like bringing like as many users and providing them like real world like use cases and real world value. So we are trying to create like a infrastructure that is very easy for use for, so that developers can use it very easily, and they can build like world class products for like the bringing in the new users.
And for the like the proof aggregation topic, so you would take these multiple proofs delivered and essentially aggregate them and submit it to Bitcoin. I guess do individual projects have a way to set the frequency of those submissions of the proofs that are aggregated? Like for unique solutions, maybe some people need like more frequent or less frequent. I don't know if you've explored it in that direction.
So currently, how we are looking at it is we are creating a regular aggregation and we are creating a fast mode. So we are talking to our clients based on their needs. So these are two different types of solutions. So on the Bitcoin side, like the max speed that we can go is like settle every single block, and that's close to 10 minutes. So like for getting even faster, what we are doing is doing the pre-confirmations. So let me just go through like how a single chain interacts with LayerEdge. So as a single chain, you send your basically a proof to LayerEdge, and when we get the proof, first there is a leaf level verification, so that to make sure that the proofs that we are getting from the chain is valid and the state change happened correctly, so that if there is any fault in the proof that you're sending, we can revert them immediately by our just our validators only. Then they are getting aggregated, and we are creating a fast mode also, which will be supported on every single block, and there will be a normal mode, which is basically every third to fourth block. And like right now, if you see, like most of the people are using the fast mode, so I think this fast mode will be like the new normal, because on the Ethereum side, the fast mode can be of like few seconds or like just like 1 minute, but on the Bitcoin side, the fastest we can go is like close to 10 minutes because of the L1 limitations.
Got it. No, makes sense that the 10-minute block times is also something where, like, I guess like the risk of app developers coming in and you make a transaction and you have to wait 10 minutes, but then having this like closer to what Ethereum block time is would be interesting. I mean, although it potentially decreases security, but increases that like usability and essentially more use cases, which is very nice that you're thinking in that direction as well.
Yeah, exactly. That's why we have the pre-confirmations. And to be honest, like of the 8 clients that are right now using us on the DevNet, like 2 of them actually use the pre-confirmations for different use cases.
And also, Ayush, curious to hear, after the proof aggregation happens, what are the steps or like the process when you're verifying the proof and then settling it on Bitcoin? So I know you guys have a settlement module for that. Could you go into some more details about it?
Yeah, sure. So, what should happen in the ideal case scenario is basically so there are 2 things happening. So one is right now on our DevNet, it was launched some time back, and it majorly focused on the aggregation module. So if you see the settlement happening there, it's basically creating a rune and settling the like aggregated proof directly to it. But that's not the ideal solution for which we are going with the mainnet. So on the mainnet, how we want to go is basically using the BitVM tech, and which we're actually building in-house. Basically, it's like everyone in the BitVM family is like forking the same repo and just modifying in their own ways. So how we are doing is basically like when we get a single proof, the aggregated proof, at the next level, basically we create our own like what can I say? A proposer creates a proposal, and then there can be multiple different challenges, and those challenges would be running the like all the computations on their own devices and making sure that that single proof is correct or not. And if it's incorrect, then the exact challenge mechanism gets triggered as in the core BitVM, and it's just the process of the verification that's pretty much different, except that the whole theoretical aspects is like pretty much the same.
And on the topic of native verification, like OPCAT has been a pretty popular discussion,
Yeah.
and in terms of like the implications when if it'll be incorporated in the future. So interested in hearing more about how LayerEdge is able to provide that native verification with or without OPCAT, and once it say is implemented in the future, what changes will come in terms of say the methods that you guys are using.
So, like without OpCat, like what we are doing is basically settling everything using the BitVM, Where the opcat becomes a game changer is how we can leverage with the BitVM2, because we are also we have a very small team who is actually researching on the BitVM2, and we found several different ways how we can improvise it. So if you go on the BitVM2 sites, then what we can actually happen is we have a verifier function. Just like think it as a big function. You can create smaller chunks, and those small chunks can do verification. Like what we can happen is you can move from F1 to F2, F3, F4, F5 in a sequential way, and you can actually do the complete verification with the help of Bitcoin scripts only. So that can happen with the help of BitVM, BitVM2 and the opcat, because in opcat that allows concatenation. So then you can actually store all the functions one after the other, and that can actually reduce the challenge. Basically, it can eliminate the challenge window. So then the verification will be like completely in a ZK way, not in an OP-ZK mix way. So that's like a pretty great thing for us. So we are just very bullish, and we are hoping for opcat to be as live as fast as possible.
So that verifier function can be split into kind of smaller chunks, and then we can do that verification with just the scripts itself in a sequential manner. Okay, got it. And also was curious on hearing some more about LayerEdge's architectural design considerations, the kind of intentions and motivations behind adopting certain components within your architecture. So for example, I know you guys use the Nubit DA for that proof storage component, and then you also use Babylon security model as well. Wanted to hear more about some of the reasoning behind those design choices.
Yeah, sure. So first of all, when we build our whole aggregation module, so as I told you, we went step by step because we followed the need of the market, and most of our partner chains that wanted solutions from us. So the initial solution that we made was completely centralized, because if you see, most of the ZK solutions are pretty centralized. So now we wanted to decentralize the solution and make sure that they can be individual different validators who can do all the processing, who can create different aggregated solutions and then can push it. So there we needed some economic security model through which we can incentivize the good behavior and punish the bad behavior. And for that we needed good amount of economic security, because as we told, Bitcoin doesn't have true smart contracts. So we cannot code let the smart contract taking care of each and every case. So when we were using these economic security models, then the second challenge that came to us was we are basically a security layer. So the capital that should secure our network should be more than the cumulative assets on all of our partner chains who are using us. So that amount is going to be huge, and as and when we introduce one new chain, the capital requirement on the security side is going to increase exponentially. And there was only a single player who can help us with that. That was Babylon, because they had huge amount of Bitcoin reserves, and that can basically secure our network. So that's why we partnered with Babylon, and what we are actually doing is they are providing the capital to make sure that all the validators who are basically creating the new aggregation proof and then just posting posting and settling and verifying everything on the Bitcoin are honest, because their capital is at stake. So that part we needed Babylon for. And then we also wanted everyone to actually understand what we are doing, because it's great for building something that's groundbreaking, but if people don't understand, they do not value the security aspects, then everything is for vain, because we'll create something pretty good, but if no one is using it, then we don't want that scenario to happen. I want to educate people as well as possible. That's why we created a light node campaign, which will go live very soon. There everyone can run a single light node and verify a single proof. That proof can be of a single chain, and then there will be incentivizations if you understand what that proof symbolifies, how the aggregation works, how the verification works, everything that we discuss in the whole podcast. So if anyone is listening to the podcast, it's a gem. You are going to get a good airdrop, because you can basically solve everything. So for making it easily understandable and easily digestible for everyone, we created a whole light node campaign through which we are also asking everyone to interact more, because it's more important for us to interact as a person than to just run a light node on a server. So for that we needed like a complete like a DA solution on which we can actually store everything, so that the guys who are running the light node, it's easier for them and easier for anyone to verify. So what's actually happening, once the aggregation process is done, it's secured, then the complete tree, like the whole binary tree, is then secured on a third party DA which is not controlled by us, so we cannot manipulate it in any other way. So we chose Nubit for that because they are like our partners and like believers in us from the initial days. So it's stored on their network, and then anyone can verify that the whole tree structure in a very cost efficient and in a very light way. They can do with our network without using any of the Nubits DAs like Merkle tree, but that would require a lot of computation. So that is for like the who are running the full node, the full validators, they can do that. But if you are running just a light node, a light validator, because I just have an iPhone, so what I wanted, the light node should be able to run on this phone, so that everyone can just run on any of the devices. So for that we are using like Nubit DA for storing the whole Merkle tree, and then you can verify single parts of it.
So even like you predict, even then within the next 5 years, we will see Bitcoin become as mature as these other ecosystems, at least on that DeFi sense. Great. And yeah, that sounds great, Ayush. And thank you so much for joining us today. And really enjoyed hearing about like how you guys are doing that heavy lifting in terms of security, but then providing protocols with this kind of easy onboarding platform to do this aggregation verification, and really trying to simplify that developer experience. So really appreciate all the insights that you've given us here today, Ayush, and hope to have you back again sometime in the future. Yeah, thank you so much, Ayush.